Hello guys, how are you? So in our today's session, we are going to talk about matrices of linear regression. In linear regression, we are going to calculate the loss and the accuracy. So in today's session, we are going to talk about that how the linear regression calculate the loss value and the accuracy value and behind the mathematics of this. So let's start with this. As you can see, we have a data and we get our best fit line, and if we consider all the orange dots and calculate by how much the amount does the prediction misses the actual, we get an error value for that point. This is the difference between y and y hat. So get the estimate of loss, we just get the difference between y and y hat. This is how we calculate the error of our model. And there, to calculate the error, we have different methods. First method is mean absolute error, which is MAE. To calculate the MAE, we first take the absolute difference between y and y hat for each available observations, yi minus y hat I, where I equals to I, the total number of points in the data set. So basically, it calculates the difference between the y and y hat predicted value and the original value, and it just remove the minus sign by doing the absolute, by calculating the absolute of that. Next next came is sum sum each absolute difference to get the total error. When we get the error of each of points, we just sum up all of those error and then divide the sum by a total number of observations to get a mean error value, which is y minus y hat, taking absolute divided by n. MAE equals to summation yi minus y hat I, absolute of that, divided by n. So basically, when we calculate the error for every point, we just take the absolute for that error, we just take the absolute for that distance, and taking summation by combining all of these distances, all of these error, and divide by the number of observation, we get the total aggregate error. And that number is termed as our loss, which you can also say as mean absolute error, MAE value. Each observation produces error value, which could be any integer. It could be 0, negative, or positive. So basically, distance can be 0, negative, or positive. So if the distance is 0, our loss is 0. If distance is negative or positive, we have some loss value. So that's all about the mean absolute error, MAE. Next comes is mean squared error, MSE. Take the difference between y and y hat for each of the available observations, yi minus y hat. After getting the difference between y and y hat, we do the square of each of the differences, yi minus y hat I, and square them and sum the squared values, summation yi minus y hat, total square, summation of that, where I belongs to 1 to the total number of points in the data sets. Divide the total number of observations, summation yi minus y hat square divided by n. MSE is equal to summation yi minus y hat I whole square divided by n. So when we calculate the distance between original value, ground truth value, and the predicted value, we just do the square of that, sum up all those errors, sum up all those numbers, and divide by number of observations. And by doing the divide by number of observations, we get the total aggregate error, and that is our loss value, or you can say that mean squared error, MSE value. These four steps should give us MSE for that model. But why we are squaring the difference? Here, as you can see, we do the square of the difference. But why we are doing? Because difference can be negative, And to get rid of that negative value, we are doing the squaring of that. So that's all about the mean squared error MSE value. Next is R squared, or coefficient of determination. This metric representation, this metric represents the part of the variance of the dependent variable explained by the independent variables of the model. It measures the strength of the relationship between your model and the dependent variable. To understand what R squared really represents, let us consider the following case where we measure the error of the model with and without the knowledge of the independent variables. So basically, R squared is telling us the strength of the relationship between your model and the dependent model. That means the how much accurate your model, what is the accuracy of your model. So R squared is tell us about that. RSS is the difference between actual and predicted value. Thus, RSS residual sum of squares can be calculated as this is the nothing but the difference between actual and predicted value. So when we calculate the difference between those actual and predicted value, we get our value of RSS residual sum of squares. And after calculating the RSS, we get go to our next step. The total variation in Y can be given as a sum squared differences of the distance between difference between every point and the arithmetic mean of Y values. This can be termed as TSS, total sum squared. So after calculating the TSS, now we calculate the coefficient of determination of R squared. By dividing RSS by TSS, we get represents the part of the variance of Y not described by the line. Next, to calculate the R square, we just do 1 minus RSS minus TSS represents the part of the variance of Y described by the independent variable. So like this, we calculate the R square value. So that's how we calculate the R square value, and after calculating this R square value, we get the accuracy for our model. So next comes the cases in R square value. If R square is high, say 1, then the model represents the variance of the dependent variable. If R square is very low, then the model does not represent the variance of the dependent variable, and regression is now better than taking the mean value. That is, you are not using any information from the other variables. A negative R square means you are doing worse than the mean value. It can have a negative value if the prediction do not explain the dependent variables at all, such that RSS is approximately equals to TSS. So that's all about the cases for the R square value. And next game is p values. In hypothesis testing, p-value is basically used as to reject or not reject a null hypothesis. Each coefficient in the regression equation has a certain effect, varying from none to maximum effect on the output or prediction. So null and alternative hypothesis can be formulated as below. H0 or H null. Null hypothesis coefficient X has no effect on the output. HA alternative hypothesis coefficient X has some effect on the output. So basically this hypothesis or the p-values states that we state some hypothesis like null hypothesis or the alternative hypothesis. We're doing some operations on like on our data, and if we get a value and that value is greater than the threshold value, then we can use alternative hypothesis. And if the value which comes out from some operations and that is less than the threshold value, then then we say we are going to use the null hypothesis, and the threshold value is called as p-value. If p-value is less than some threshold value, it means that we can reject the null hypothesis and say that coefficient feature predictor has same effect on the output. If p-values is greater than a threshold, the features are not significant statistically and hence not contributing to the prediction. It might be another mini post to actually get in how this p-value is calculated. So here we can by mistake I think I said that p-value is threshold. but p-value is not that threshold. By doing some operation, when we get the value, that value is called as p-value. And if p-value is greater than the threshold, then we can say that the features are not significant, we are not doing some good work. And if the p-value is less than the threshold value, then it means that we can reject the null hypothesis, and we can say that we have some effect on our output, and that means we are going in a good direction. So that's all about the p-value, and that's all for the today's session. That means the matrices of the linear regression, that how p-value is used in the linear regression, the cases in R squared. Then we're gonna talk about how R squared and the coefficient of determination is calculated, and how mean square and MSE is MAE, and mean square error or mean absolute error is calculated, and how it is used to tell us about the loss value, about the loss for the linear regression model. And that's all for the matrices of the linear regression. So that's all for the today's session. I would just want to suggest you that do some more research and development, do R&D on this, and try to get some more insights by doing some research on the matrices of linear regression. And maybe you find some more, but here it is not possible to explain the whole of the things. So I just recommend you that you can do the R&D on this linear regression, matrices of the linear regression. So that's all for the today's session. Thank you, bye bye, take care, stay motivated and keep learning.